February 20th, 1943, north of Kasserine Pass, Tunisia. The German after-action reports would never truly capture what their tank commanders witnessed that morning. Through the haze of dust and smoke, 5 American Sherman tanks moved as if guided by a single mind. Separated by ridges and gullies with no line of sight between them, they maneuvered in perfect synchronization, converging on German positions with coordination that seemed supernatural. No flags waved, no signal flares burst in the air, no messengers dashed between vehicles. Yet each tank covered the blind spots of the others, moving as a single, unified organism. The bewildered Panzer commanders, shouting into their few G5 radios, could barely hear their own orders through the static. Their 10-watt transmitters, cutting edge by 1930s standards, barely reached a few hundred meters under movement. Most German tanks carried only receivers, meaning they could listen but not speak. What the Germans faced that morning was not just another tank formation, it was the future of warfare. The Americans were operating with technology the Wehrmacht didn't even know existed. Inside, every Sherman tank hummed a crystal-controlled frequency modulation radio, the SCR 508, transmitting 25 watts of clean, stable power. It cut through engine noise and battlefield chaos like a knife through paper. Thousands of miles from Detroit's factories, the most decisive technological advantage of the war was revealing itself, not in steel or firepower, but in invisible electromagnetic waves connecting every American crew in a living network. The transformation had begun back in July 1941, when the U.S. Army standardized the SCR 508, 528, and 538 radio sets for all medium tanks. While German engineers perfected tank armor and optics, American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting something far more decisive. Daniel E. Noble and Henryk Magnuski, pioneers of FM communication, built the first radio system that allowed tank crews to talk clearly, instantly, and reliably in combat. Their design weighed 181 pounds and turned every Sherman into a node in history's first battlefield communication web. The BC-604 transmitter delivered over twice the power of the German Fuji-5, operating across 20 to 27.9 MHz with 10 preset channels. Its dual BC-603 receivers allowed commanders to monitor multiple networks simultaneously, platoon, company, and artillery, all without confusion. But the real revolution lay in the signal itself. Edwin Armstrong's frequency modulation technology eliminated the static that crippled older amplitude modulation systems. While German tank crews listened through hissing noise polluted by their own engines, American tankers spoke in clear, calm voices even under artillery fire. When Operation Torch landed U.S. armor in North Africa in November 1942, this invisible edge immediately showed its worth. The Africa Corps, the most experienced armored force in the world, was suddenly facing an enemy whose tanks coordinated like a swarm of synchronized predators. The German system depended on rigid hierarchy. In a standard Panzer platoon of 5 tanks, only 1 or 2 could transmit. The rest were effectively mute, awaiting visual cues from the command vehicle. When that vehicle was destroyed, often marked by its distinctive antenna, the entire platoon fell silent. In contrast, every American tank could command, report, or request support. At Kasserine Pass in February 1943, this difference became undeniable. Even as units scattered across 50 miles of desert terrain, American crews maintained communication, coordinated attacks, warned one another of ambushes, and called artillery strikes within minutes. The Germans intercepted American signals and were astonished. The transmissions were crystal clear at distances where their own sets produced only static. By the time the fighting moved to Italy later that year, FM superiority was even more apparent. In the mountains around Cassino, where radio signals bounced unpredictably, American frequency modulation worked flawlessly, while German AM radios failed completely. Sherman crews separated by ridge lines still coordinated their fire with surgical precision. Then, in June 1944, as American tanks rolled off landing craft at Normandy, those same SCR-508 radios kept contact not only between tanks, but with naval fire support offshore. Something German technology couldn't dream of. Yet even this system had limits. Tank radios and infantry radios worked on different frequencies, and in the bocage, that gap cost lives when infantry couldn't warn tanks about hidden Panzerfaust teams. But by July, a simple American innovation, field telephones welded to the outside of tanks, closed that gap, creating the first true tank-infantry communication link. Operation Cobra, later that month, proved the full power of the network. The U.S. 2nd Armored Division, under General Edward Brooks, coordinated more than 200 Shermans with radio precision that German commanders described as supernatural. Artillery fire landed within minutes of contact reports. Tank destroyers maneuvered toward targets they couldn't even see. Guided by radio calls from other units, the Germans, once masters of mechanized warfare, now fought in isolation. Their vaunted Panzer Lehr division, crippled by destroyed antennas and short-range radios, was effectively blind and mute. The irony was cruel. Germany had pioneered tank radio doctrine under Heinz Guderian, whose 1937 book, Achtung Panzer, declared communication essential to armor warfare. Yet by 1943, German industry could not equip even half its tanks with full radios. The numbers told the story. America produced over 50,000 SCR-508 sets, enough to equip every one of the 49 324 Shermans built. Germany produced barely 6,000 few G5 units for over 12,000 medium and heavy tanks, leaving most with only receivers. The difference in power, clarity, and stability was staggering. The SCR-508's 25-watt transmitter maintained contact over 10 to 15 miles, while German AM sets managed only a fraction of that, often failing under movement. Even Soviet tanks fared worse. Most T-34s rolled into battle radios silent, relying on flags. Only 25% of Soviet tanks had radios by war's end. America, by contrast, achieved 100% radio deployment. The impact was profound. The SCR-508 wasn't just a communication device, it was a force multiplier. Commanders could form flexible, ad hoc battle groups, confident that every tank could integrate instantly. The system's dual receivers allowed officers to track multiple nets at once, while intercoms linked every crewman. Throat microphones and noise-canceling headsets ensured clarity even under fire. Power regulators filtered electrical interference, something German sets couldn't manage. In battles like Ericourt in September 1944, this advantage turned the tide. Facing superior Panther tanks, the U.S. 4th Armored Division destroyed 281 thieves, German vehicles, while losing only 41 Shermans, a 7-to-1 ratio driven largely by communication superiority. Yet the Germans never understood the true cause. Intelligence reports credited American coordination to training and discipline, never realizing the role of FM technology. They continued targeting command tanks, unaware that every Sherman could issue orders. By the time they grasped the scale of the gap, it was too late. In March 1945, during the race to the Rhine, radio coordination allowed American units to seize the Ludendorff Bridge at Remagen within hours of its discovery. Orders flowed instantly up and down the chain of command. Reinforcements shifted in real time. German forces, dependent on telephone lines bombed to ruin, reacted too slowly and too blindly. By April, as American forces encircled the Ruhr pocket, radio networks held the operation together. Entire armored columns coordinated double envelopments purely through radio communication. German troops trapped inside, 325,000 in total, found themselves isolated, their communication shattered. Field Marshal Walter Model's last transmission captured their despair. No contact with adjacent units. No communication. Coordination impossible. For American tank crews, the psychological impact was just as important. Even when surrounded, they knew they were never alone. German crews, isolated in their steel coffins, fought blind and silent. Otto Carius, one of Germany's top tank aces, later described the loneliness of battle without communication. The uncertainty, the helplessness. The Americans never faced that. Their connection was their confidence. Their network was their armor. After the war, captured reports confirmed what veterans already knew. U.S. technical intelligence concluded that German radio technology lagged at least 5 years behind American systems. The Red Army, too, studied captured equipment and chose to copy American FM designs for its post-war tanks. Even Germany's new Bundeswehr in the 1950s made radio communication its highest priority. A training manual summed up the lesson bluntly. The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. That lesson has echoed through every war since. In the 1991 Gulf War, and again in 2003, American forces with advanced communication networks destroyed opponents whose individual tanks were stronger but whose coordination was primitive. The principle remains the same. The network beats the platform. The connected defeat the isolated. When historians call the Sherman tank the most important tank of World War II, they're not talking about its armor or its gun. They're talking about that 181-pound box of circuits, tubes, and crystals, the SCR 508, that made every Sherman a node in history's first digital battlefield. It was the invisible weapon, the unseen link that turned thousands of tanks into one unified fighting machine. As Field Marshal Wilhelm Keitel reportedly said at Germany's surrender, "We knew how to build better tanks, but you knew how to make them work together." Whether he truly said it or not, the truth stands. America didn't just build tanks, it built a network. And from that moment in 1942, warfare changed forever. The side that could communicate would always defeat the side that could not. In the end, the invisible waves of radio, not the shells or armor, decided victory.